Question 11, we've got this rod here and it's leaning against a rough wall here, and we're going to take the moments about this part here to start with. So we've got the weight pulling it down, we've got mg here, and we've got a cable here holding it up, or a piece of string holding it up with some tension in it. There's an angle there of alpha. We're going to figure out things to do with alpha first of all. We're told that the tan of alpha is 5/12. And so if we draw ourselves a little triangle here and put 5 and 12 there, we can see that the other bit there is going to be 13. And so let's write down these so we can use them later, is that the sine of alpha is 5/12 and the cos of alpha is over 13. 12/13 and 12/13 there. So moments about B. So B is being dragged down to the anti-clockwise with mg, force, and a distance. And the distance there to there is half of the length of the rod. And what's holding it up? Well, it's the tension times by the length of the rod. But here, look, there to there doesn't meet it at 90 degrees. What we want is actually this distance here, which meets it at 90 degrees. And if you look at that triangle there, that one over there is opposite the angle, so it's the sine of alpha we want in here. That's 5/13 equals 0. The L cancels on both sides, and so I've got T equals times by 13. I've got 13 mg and divide by the 5 and also the 2, 13 mg over 10, which is what you're asked to show. Now for part B, we're going to look at the forces acting on this. And so I've got my rod here, and we know that there's mg pushing down here. But this cable here that we now know has got this tension here is actually pulling up a little bit. It's pulling up with a force of T sine alpha, and it's pulling across to the left with a force of T cos alpha. So let's put that on here, T sine alpha and T cos alpha. The wall here is pushing off to the left with some normal reaction force, and there's the friction going up the wall here that is going to be mu times the normal reaction force. Let's resolve. I'm going to start resolving horizontally. So going to the right, I've got T cos alpha. Cos alpha we did earlier was 12/13 minus R equals 0. And so that tells me that R is going to be, so what was T? T was 13 mg over 10 times by 12/13. Let's cancel these 13ths, divide by 2. So I've got R is 6/5 mg. Now let's resolve upwards as well. So upwards, I've got T sine alpha plus mu R minus mg equals 0. Lots to substitute in here. Let's take it slowly. So T, 13 mg over 10. Sine alpha is 5/13 plus mu R, and we've got the R there, 6/5 mg minus mg equals 0. Well, look, we've got an m in all of those, they can cancel. We've got a g in all of those, they can cancel. Those two 13s there, that can cancel. So what have we got? We've got a total of 6/5 mu here equals 1, and that's just 5/10. So 1 take away a half. So if that's a half, times by 5/6, and we've got the answer 5/12.